In this next example, it's going to ask you to find the volume infused and then the duration of an infusion, or the duration for a certain volume to be infused. Okay, so the problem says a patient is receiving an infusion at half a milligram per minute, and it says the concentration in the IV piggyback bag is 100 milligrams in 200 milliliters. And the first part of the question says, how long will it take the patient to receive 40 milligrams? Okay, so 40 milligrams is equal to how many minutes? All right, so we're going to take the 40 milligrams and multiply by 1 minute over half a milligram. So 1 over 0.5 milligrams. All right, so if we want to eliminate the units of milligrams and convert the 40 milligrams into minutes, okay, we got to multiply by 1 divided by 0.5. Okay, so we eliminate the units of milligrams. So remember, multiplying by 1 has no effect, so we're gonna take 40 and then divide it by 0.5 on our calculator. So 40 divided by 0.5, all right, is equal to 80. I guess the answer is 80 minutes. Okay, so you probably already know, and you should know, that 1 hour is 60 minutes. Okay, so if you want to convert this time into hours and minutes, you can. Okay, so since 1 hour is 60 minutes, right, and 80 minus 60, so 80 minus 60 is 20, right? So you have 1 hour with 20 minutes left over, right? So in other words, it'll take an hour and 20 minutes, right, for the patient to receive 40 milligrams. Okay, let's go look at the next part of the question, and it says, how many milliliters will the patient receive in 30 minutes? Okay, so 30 minutes, okay, is equal to how many milliliters? Okay, so for obvious reasons, we're going to start with the 30 minutes. All right, and because the patient is receiving the drug at a rate of 0.5 milligrams a minute, let's go ahead and convert that into milligrams first. Okay, so we're going to go ahead and multiply by 0.5 milligrams over 1 minute. Okay, so we eliminate the units of minutes. Okay, so 30 multiplied by 0.5. And remember, dividing by 1 has no effect. So on our calculators, we're going to plug in 30 multiplied by, okay, 0.5. Okay, we get 15. So this is equal to 15 milligrams. Okay, so over the course of 30 minutes, okay, the patient is going to receive 15 milligrams of the drug. Okay, but now what do we do, right? It's asking how many milliliters will the patient receive in 30 minutes. Okay, so now that we know the number of milligrams the patient will receive, we can convert the number of milligrams into milliliters by using the concentration given in the problem, which says that it's 100 milligrams in 200 milliliters. Okay. Okay, so we can multiply by the following fraction. So multiply by, so times, okay, so we want to eliminate milligrams. So we're going to multiply by 200 milliliters on top. All right, and then 100 milligrams in the bottom. Okay, so we have to flip over the concentration accordingly. All right, and in the process, we eliminate the units of milligrams. Okay, so on our calculators, we're going to do 15 times 200 and then divide by 100. All right, we get 30. Okay, so over the course of 30 minutes, all right, the patient will receive 30 milliliters. Okay, and that completes this question on volume infused and then duration. Okay, so in the first part of the question, we figure out the duration for the patient to receive 40 milligrams, so how long it took, or how long it will take for the patient to get 40 milligrams of the drug. All right, and then in the second part of the question, we figured out how many milliliters the patient will receive in 30 minutes. Okay, so in the homework, you'll see a very similar question. However, it'll ask you for one thing or the other, but not both. Okay, but it's always good. It's always a good practice to know how to answer both questions. Okay, so the last two examples we're going to do involve problems with compound rates. Okay, so compound rates are described starting on page 317 of the ebook. Okay, so I encourage you to read this brief section so you can understand what compound rates are and how to set them up properly. Okay, but I'm going to really quickly read a few sentences here. So, in this chapter, okay, some IV medications are prescribed not only based on the patient's size, the amount of drug the patient receives also depends on time. Okay, so for example, an order might indicate that a drug is to be administered at a rate of 2 micrograms per kilogram per minute. Okay, which could be sometimes expressed as 2 micrograms / kilogram / minute. So this means that the patient is to receive each minute 2 micrograms of the drug for every kilogram of body weight. So therefore, the amount of medication the patient receives depends on two things. Okay, the patient's weight and then the time. Okay, so this new type of rate, which is called a compound rate, for computational purposes is written as follows. Okay, so if you see something like this, right, like micrograms per kilogram per minute, right, this is a compound rate, right, and the way that you write it out is that the units that appear first go in the numerator, okay, and then the other two units both appear in the denominator. All right, and you can insert a multiplication symbol. So what they did here is they put the kilograms in the denominator and then the minutes also in the denominator, and they separated them with a dot, okay, which is not to be confused with a decimal point, but here the dot means multiplication. Okay, so you can kind of think of the dot there as kilograms times minutes. Okay, then they go on to describe how to work with such a compound rate, and then they do some examples. Okay, so we'll do a couple of examples from the book. So one of the examples we're going to do is 11.12. Okay, so let's go ahead and take a look at it. So the problem says the prescriber ordered 250 milliliters of 5% dextrose in water, so that means dextrose in water, with 60 milligrams of a drug. And then here's the compound rate here, so 0.006 milligrams per kilogram per minute. IV piggyback daily. Okay, so it tells us the amount of fluid, the type of fluid we're using, the amount of the drug, and then the rate at which the drug is to be prescribed. Okay, which is based on the patient's weight and the amount of time in minutes. Okay, and the problem says that the patient weighs 75 kilograms. All right, and the drop factor is 20 drops per milliliter. All right, so it wants us to calculate the flow rate for this drug in drops per minute. Okay, so there's a lot going on in this problem, so we're going to take it step by step, and then hopefully it'll all come together at the end. Okay, so the basic idea with a problem like this is that we're using the formula size of patient multiplied by the rate. Okay, the compound rate given in the order is going to be equal to the dosage rate. Okay, so it's very similar to a previous formula which said that the size of the patient times the order is equal to the dose. But here we're taking the size of the patient, multiplying it by the compound rate, okay, in the problem, and then getting the dosage rate. Okay, so that's going to be our first step. Okay, so we're going to take the patient's weight in kilograms, okay, which is 75 kilograms. So 75 kilograms multiplied by the compound rate of 0.006 milligrams per kilogram per minute. Okay, so in the process, we eliminate the units of kilograms. Okay, and we're left with the units of milligrams in the numerator and the units of minutes in the denominator. Okay, so the only two numbers that we're going to multiply in this problem here, this calculation, is 75 times 0.006. Okay, so we need to figure out what that is. So 75, okay, times 0.006. All right, then we get 0.45. Okay, so that's the drug rate in milligrams per minute. So 0.45 milligrams per minute is our drug rate. Okay, and once we have the drug rate, we can figure out the flow rate. So 0.45 milligrams per minute, okay, is our drug rate. Okay, so is the rate at which the patient is receiving the drug. Okay. All right, so our final answer is going to be in drops per minute. Okay, so we're not quite there yet. Okay, we are eventually going to use the drop factor, which says that 20 drops is equal to 1 milliliter. Okay, so the other piece of information, other than the patient's weight and then the compound rate. Okay, so we're done with the compound rate. We don't need that anymore since we have the drug rate. All right, so other than the weight, the drop factor, and this compound rate, okay, the only other information is that the volume of solution is 250 milliliters, okay, and it contains 60 milligrams of the drug, okay. So what we're going to do then is convert the dose rate into a flow rate. Okay, so once again, our next step is to now convert this dosage rate into a flow rate by using the fact that 250 milliliters of solution contains 60 milligrams of the drug. Okay, so once again, this dosage rate is going to be multiplied by 250 milliliters, right? So we want to get rid of the units of milligrams. Okay, let's not worry about the units of minutes just yet. Okay, we may want to keep that there. Okay, we may change it later, but let's go ahead and leave that alone. So we're going to multiply by 250 milliliters, okay, over 60 milligrams. Okay, and we eliminate the units of milligrams in the process. Okay, so on our calculators, we're going to do 0.45 times 250 divided by 60. Okay, so 0.45 times 250. And then divide by 60. All right, and that gives us 1.875. So 1.875. So 1.875 what? Right, so what are the units of that? Okay, so the remaining units are milliliters over minutes. So we now have the flow rate in milliliters per minute. Okay, once we have that, we can use the drop factor to convert it into drops per minute. Okay, so we don't need to change the minutes into hours. Okay, we can leave that alone. Okay, so then our last step then is to multiply by 20 drops over 1 milliliter. So we're essentially going to multiply 1.875 times 20. Okay, so in the process, we eliminate the units of milliliters. Okay, and we have the desired units in the numerator, which is drops, and then the desired units in the denominator, which is minutes. So 1.875 multiplied by 20, okay, is equal to 37.5. Okay, so the answer is then 37.5 drops a minute. So that's the flow rate. Okay, so we started by multiplying the compound rate by the patient's weight to get the dose rate, and then we converted the dose rate into milliliters per minute by multiplying by the reverse of the concentration, and then we multiplied that by the drop factor to get the flow rate in drops per minute. So I encourage you to view the solution to this problem in the book